Well, right there, I'm on the 15, and in the middle, it's up floating around anywhere, between here and here. It's floating around at 7 and 8, and then it goes back to 15 down here, so I'm going to call that good enough. For some reason, I was thinking this went up to 90 degrees. That sucks. Hey guys, welcome back to the shop. My name is Doug. Was hoping to have a making chips video for the Christmas weekend, trying to get it out. Hopefully I still can. I bought this Pongren vise maybe 2 years ago, and I haven't really used it much, but I could have sworn it went up to 90 degrees. It's adjustable. No, it only goes to about 50, so it does 45, but it goes past it. There's a marks over here on this side. It goes to 50, so I'm making it will go up to 90. Hell, to go all the way over really. But these are the brackets that are on it. There's 2 of them. And they basically go on these studs right here. Let me bring you over here. Goes on like that, and then catches that stud, and it just swings. It stays on all the time, and then it swings down. So I'm going to measure between the 2 studs here, get my center, which I've already done, and it's 13 5/8 centered. They're 3/4 inch studs, and I'm going to go do some AutoCAD, and I'll bring you back and show you what I'm coming up with. I want to kind of make something that catches the 2 studs, but I don't want to make a small skinny bracket like that to hold it up at 90. I want to make it a little more beefy, and basically use the back of the vise as a place for it to set, stability, so it's not dependent on pushing on the stud. It'll push on the vise itself, or the base of the vise. So I'll go over to AutoCAD and we'll come up with something. Alright, this is what I came up with. Kind of use the same design as what's on the other bracket, because I need to make some clearance, because it won't be able to swoop up through here off of this pin, because it'll hit the base of the vise. So I had to basically come up, so I basically drew it straight at 90, something 13 5/8 centered holes with 3/4, and then I had the degree angle of well, I can't remember what it is. It was like 36 degrees or something, so I turned it and leaned it over, and then I squared that up and brought that up. This is the bottom or the top of the mount of the vise, so I came up that high, which is about 1.5 inches. It's all drawn out in thousandths, because I measured everything off the vise, but this is kind of what I came up with, and it's going to come all the way back to the back of the vise, and those are bolt holes, because I'm going to put a piece that's going to set on the tabs on the back of the vise and support it. So it'll pin here and here, and then there'll be another bolt, or a set of bolts there, one on two on each side, with a 3/4 inch plate that's basically, you know, gusseting onto the base of the vise. Don't know if it'll work, other than nothing to do but do it. So we'll get to cutting that out. I'm going to test one before I cut the second, just to make sure measurements are kosher. But got everything laid out in CAD and laid down on the so that's a 4x8 sheet, kind of where I want it. So I got all that, and I got the tool paths already set up and the post processor, and got it, created the G code, and there's the file for the Mach 3, and I'll show probably a little bit of it. Probably cutting a 3/8 plate, it's going to take a hot minute. It's only going to travel at 18 inches a minute, so it'd probably take 3 or 4 minutes for that to cut out. Alright, I got everything cut out, and this is the right side. See here what it looks like. It should just go right on. Now the holes I cut small, and then I ran a reamer through them. I have an old reamer, just because of the flame cut. You're going to destroy a reamer trying to ream these out, because it did cut with a little bit of taper. It would have went on if I'd have beat it on, but I didn't want to do that. Which side is this? Left. I'm also going to take my letter stamps and I'm going to mark right and left on it, because the studs placement on both sides aren't the same. They didn't measure the same, so I have a right and a left side for where the center of the pin is. So this was really close to 13 5/8, and I think that side was just a smidge over that. But see, once it goes up onto the stud where there's no threads, I mean, it's a really nice fit. I even have them marked inside, so whenever I stamp them, I'm going to put like right side, inside, you know, or I'll just remember that whatever side they're stamped on is the inside. You know, I'm not too worried about this bottom pin down here either. That is 1 1/8" pin, and it's actually, I think it's actually a little bit bigger. I haven't taken it apart yet to clean this thing, but that's just a thread, and then you got the the pin on the inside on one side. I can't remember how it is because I'm pretty sure these are, there's a clamp, there's some studs here on the back that draws it down tight. It clamshells it around that pin, and then you can tighten it up here. There's two big nuts. So it's pretty snug. This thing, you know, basically won't move. Now, I'm sure it does a little bit, but for as old as it is, and I'm also trying to move my mic around in different spots because I know a lot of people, they have it right here and you can hear them breathe all the time, and it's, you know, I don't like that. So I'm just using a little nut driver. It's 1/16" nuts, using a 1/4" drive, just snugging it up, you know, just so I don't have to wrench on them. But then I'll leave this one a little loose so I can get the other plate in. And I stamped this too. I got plate, holes drilled and tapped. And then I also marked it for the top and the inside, so I'll stamp on this top, inside, or top, and then I'll remember it's all the stampings are on the inside. But it'll go back here and set. Need 3/8, what is it, 3/8 16 or something like that. It's the coarse thread 3/8 bolt. Just enough to hold it. And the plate, I cut it out back here on my bandsaw, made it a little long. It should be, it's 8 1/4 inches between the two. It's 8 1/4 inches between them, and then I cut it like 8 3/8 or something like that, and then I brought it over to the mill and straightened one side, and I used a 3/4 inch end mill. And then once I got that side straight, I zeroed out my DRO and moved it over 0.75, zeroed it out again, and went 8 1/4 inches, and then zeroed it out again, and then moved over and kept trimming off that side till I had 0 on the DRO, which would have made that 8 1/4. I mean, it could have been a nice little video, but I'm kind of rushed to kind of get this done so I can make some chips on this thing. But there it is, and turn this back on. Set that at 0. It's showing 89.80, so it's damn close to 0 up there on the slide part of the that movable jaw is 89.60. $89.80. 0 on the trying to remember what degree that was, because that changed actually when I came up off of that bolt. I had to lay it out at that degree and then move everything, but I'm pretty sure it was, yeah, I don't know. But anyways, it's about dead on 90 degree, or, you know, I think that should work just fine. I'd hope, I think. I mean, because I've used this vise with this thing already at 45 degrees, and then these brackets here, they hold it just fine. I actually did the V-way on my tailstock for my lathe with it, because I got that was from a 17-inch lathe I found in a scrapyard, and then I took my shaper and took an inch off of it and then put a new V-way in it that matches that table, or matches that bed, you know, and it's right there. I've been using that for a year, and that's a nice tailstock. I don't even know what the lathe is from. But anywho, I guess we'll get this thing set up, and I got a big chunk of steel that I wanted to chew up with it. Piece of scrap. It's a part of a die from work that's junk, so I'm going to use it, and it's also going to put this thing to the test because it's a big chunk of stainless. So I'll show you that. It's just big. It's probably 4x4 inch, and it's just the top part of a die. It was for testing before we did it. Before I made them out, you know, out of tool steel and had them hardened and all that, we ran this die for about a week, and it beat the crap out of it, but it proved that the idea worked. So yeah, because this chunk of stainless, it was so mushroomed and everything. I already put it in my in the mill and just went around the edges and took off all the mushroomed ends on it. It was pretty bad. Alright, here's a 30 thousandths cut at 2 1/8 inches a minute at about 525 RPM, I think. 529. I was told I should be able to cut 100 thousandths with this. Maybe not on stainless, but should be able for sure on steel. Oh, see that. Once I get down here, I'll pull it out, look at the surface finish on it. It is cutting a little bit on the upstroke. Not much, but it is. Yeah, I guess that ain't too bad. I probably could have went a little faster. I mean, the cutters, I did rotate them to a good cutting side. And it's smooth. Yeah. I didn't mess around with my speeds, I guess. I think it could have went a little faster or fed a little faster. Still learning. A lot of chips on the floor. I have to take my boots off before I go in the house, that's for sure. Get screened at. Yeah, there's the chips. Like I say, there's a lot of the small stuff. So that's why I'm thinking I could have probably pushed it a little harder, fed it a little faster. That way I can get all the, you know, the 6s and 9s out of it. You know, maybe a little bit bigger than that. I don't think that's too durable hateful. I was just, I've seen them ran, I've watched them run, but I've never operated one myself. So starting out with light cuts, and then as I get used to it, basically the same thing as my shaper. I didn't know what it was really capable of until I got used to it and I knew what it would cut. So it's just going to be a learning curve for me. It works great. It makes a mess. I got chips everywhere. The horizontal part, I need to wait just because of this bushing. And a lot of people probably don't know this. But here's all my, you know, the bushings for, I can get it, I can press that in, but it, see, it won't turn. I talked to Mr. Grundy on the, sent him an email, he called me back. He said a lot of them don't have it anymore, but there's supposed to be a piece of oak in here holding that gap, because this is sprung, and then there's a piece of oak supposed to be in here that holds the tolerance, so it's a slip fit, and it also saturates with the oil and helps oil spread and stuff like that. But a lot of people don't have that piece of oak wood in here anymore, so I'm working on that. I got an old piece of oak here, and I'm gonna, it's got to be about 80 thousandths, I think it's measured like 82 thousandths. I put shims in here and spread it, and got this to where it was a real tight fit. You know, I could drop it and it would slowly go down. So around 80 thousandths piece of wood needs to go into there, because I could tell all this, I had to machine all this off. I had to take an end mill and go around and cut a lot of this off so I could get the nut off. This nut wouldn't come off because of the threads being all smashed from them using like a dead blow or whatever, but it mushroomed all the threads and I couldn't get it apart. But see, I mean, I could get it in there, I could tap it down in there, but then I'd need to spread this gap in order to get it out. See, it's it's tight. So, you know, a lot of people machine these out. I'm not going to do that. I'm going to put the piece of wood back in it. That way it's adjustable as the wood saturates and starts to collapse or whatever. You know, so I'm going to start a little big, and you can use the nut to, you know, loosen or tighten the taper. So that's what I'm working on now whenever I have time. Alright guys, thanks for watching. Hit the subscribe button if you like the content. There's going to be a lot more. And, you know, leave a comment. You know, I'll reply to it. I try to. And, you know, join me over on Instagram. It's metalworks_machine_shop. So, hey, we'll see you in the next video.